Modern wars in the Middle East do not begin with tanks crossing borders. They begin with airstrikes and missile salvos aimed at anything a satellite can see. Iranian radars, fuel depots, and surface missile batteries have all been hit in the last decade by precision-guided weapons launched from hundreds of kilometers away. Each strike has repeated the same lesson. Any launcher, jet, or radar sitting on open ground is living on borrowed time. Iran's answer was not to build bigger missiles on the same exposed bases. It was to move the entire system that supports those missiles underground into rock that bombs and surveillance struggle to reach. The idea of missile cities can sound dramatic, but in engineering terms, it means something very specific. These are not single bunkers with a few launchers hidden inside. They are long networks of tunnels and hardened caverns carved into mountains and desert plateaus, deep enough that the rock overhead acts as armor, and wide enough that large transporter erector launcher vehicles can move through them. Iranian videos and controlled media tours show straight tunnel sections where two missile trucks can pass side by side, overhead clearances high enough to store medium-range missiles vertically, and side galleries that branch off into storage bays, command posts, fuel rooms, and living quarters for the crews who run them. A launcher drives in from a concealed entrance, follows a tunnel that bends and kinks to limit blast effects, pauses near a heavy blast door, and then rolls out for only as long as it takes to raise, fire, and retract the missile. The visible part of the system is on the surface only for minutes. The rest of its life happens inside the mountain. The choice of location is part of the design. Many of these complexes sit under hard rock in coastal ranges along the Persian Gulf and Sea of Oman, close enough that ballistic or anti-ship missiles can reach shipping lanes quickly, but far enough inland that a cruise missile has to traverse layers of air defense to reach the tunnel mouths. Others lie in western mountains oriented toward Israel and US bases further west, and still others in central provinces like Semnan and around Natanz, where missile basing overlaps with nuclear-related infrastructure and test ranges. Iranian officials claim that most provinces now host at least some form of underground missile infrastructure, and analysis of satellite imagery supports the existence of dozens of distinct tunnel complexes tied into this network. What links them is not a single weapon type, but the way the tunnels allow storage, movement, fueling, and launch to happen out of sight. The engineering logic behind this model starts with geology. A reinforced concrete bunker on flat ground can be targeted with a single precision weapon once its coordinates are known. A tunnel, driven 80 to 100 meters into granite or similar hard rock, with tens of meters of overburden above its roof, forces an attacker to deliver energy deep into material that absorbs shock and fragments rather than failing cleanly. US deep penetration bombs are assessed to be able to reach on the order of tens of meters into concrete and rock under ideal conditions, not hundreds. Iranian media and sympathetic outlets have claimed that some of their missile cities sit as deep as 500 meters below the surface, a figure that is likely an exaggeration but communicates the design principle: depth is used as armor. The tunnels themselves are not straight lines. Satellite and ground imagery suggest that entrances zigzag behind earth berms and concrete chicanes, with blast walls that block a weapon from drawing a straight line of sight into the interior. If a cruise missile detonates at the tunnel mouth, much of the blast is absorbed by these sacrificial structures instead of directly hitting stored missiles or vehicles deeper inside. Depth alone does not keep a system functioning under attack. The tunnels are laid out with multiple portals on different faces of the same mountain or hill mass, so that if one entrance is cratered or collapsed, others remain available. Some entrances have been observed being deliberately covered with trucked-in soil and rock, then reopened later, as Iran cycles which mouths are active and which are decoys. Analysts describe this as compartmentalization. Sections of the tunnel are isolated by blast doors and reinforced bulkheads so that damage in one segment does not propagate to the rest. Inside, the floor is finished to support heavy vehicles, sometimes with embedded rails or turntables that allow large mobile launchers to be repositioned in tight spaces. Fuel and oxidizer are stored in separated bays, with blast separation between them, to reduce the chance that a hit in one compartment cascades into the entire facility. The effect from an adversary's perspective is that even if a strike can damage parts of the network, there is no single point whose loss disables the whole system. What these underground networks enable is a style of missile and air operations that assumes the surface will be a contested, lethal environment from the first minutes of a conflict. Iran's Islamic Revolutionary Guard Corps has shown underground halls packed with medium-range ballistic missiles such as Imad, Sejil, Qadr, and Hajj Qassam, loaded onto road-mobile launchers that can move from one end of a tunnel to another without being seen by satellites. Other videos show rows of cruise missiles and loitering munitions staged in side chambers ready to be moved to temporary launch points. There are separate drone caves where unmanned systems are assembled and armed underground before being moved outside for takeoff. The same logic has now been extended to manned aircraft. In 2023, Iran unveiled Ogab 44, also known as Eagle 44, its first acknowledged underground Air Force base. Built inside the Zagros Mountains, it contains hangars, maintenance bays, fuel storage, navigation equipment, and an alert area capable of hosting legacy F-4 Phantom fighters and other aircraft armed with long-range cruise missiles. The goal is not to make the jets more advanced. It is to make sure they and the weapons they carry are still there after the first wave of strikes. From a strategic point of view, the strengths of this approach are clear. Putting launchers and aircraft under hundreds of meters of rock makes them much harder to destroy in a single coordinated blow, especially when entrances are dispersed and disguised among decoys. That survivability underpins deterrence. Iran's leadership can argue that even if an adversary hits early and hard, enough of the underground force will remain to retaliate, and that this possibility should give those adversaries pause. The tunnels also enable movement and deception. A missile seen entering a tunnel at one location may emerge hours later from a different mouth, making pre-planned targeting far less reliable than against fixed above-ground silos. The psychological effect is part of the design. Periodic releases of footage from inside these facilities are intended to remind viewers that much of Iran's strike capability is in places the cameras will never fully show. The limits are just as structural. Tunnels need entrances, and entrances exist at fixed points on the surface. Those points can be found, monitored, and targeted, even if what lies behind them is harder to reach. Excavating and maintaining kilometers of underground highway-sized tunnels is enormously expensive in terms of concrete, steel, ventilation systems, power, and trained crews to operate and repair them. That cost is sunk into rock and cannot be redeployed elsewhere if strategy shifts. Depth and overburden reduce vulnerability to many conventional weapons, but they do not make a facility invulnerable to everything. Very large penetrating bombs, repeated strikes on the same location, or attacks aimed at collapsing tunnel mouths and access roads can still degrade the system's ability to move and launch. And because these missile cities are designed around the assumption of surviving and firing back after being hit, they do nothing to slow escalation. In some scenarios, adversaries may even feel pressure to strike harder and earlier, precisely because they know what is hidden under the mountains. What Iran has built under its mountains is not a guarantee against defeat. It is an infrastructure response to a specific pattern of attack. If modern war in its neighborhood begins in the air, with precision-guided weapons aimed at anything visible, then Iran's answer has been to move as much of its strike capability as possible into places that are hard to see and harder to hit. The missiles and jets that emerge from those tunnels get the attention. The decisive factor in whether they ever get that chance is the concrete, rock and logistics laid out of sight beneath the ridgelines.